Dear students, please pause the video until you have fully understood the workings or solutions of the example of questions. Or you may rewind to watch a step or part of the working solutions of the example of questions. If you are still unable to follow, please do ask your lecturer during consultations or seminar or support class. Or you may make appointment with your lecturer for further clarifications. Thank you. I'm Mr. Heng. In the second video, you have seen the note on this. How do you express in mathematical term to do copy or take a pictures of this, because you must not make a mistake with the inequality sign. So please download the statistical table from Blackboard under the learning material. So you will see down there is a statistical table. So please download the table. You will need it for the next example. So these are the three tables that you may need to use it. I will use one example to explain to you how to use this. So in this case, your n is the number of tries from 2, 3, 4, 5, and so on until 8. And your probability is 0.05, 0.10 until 0.50. So this is the first table. Second table, and from 9, 10, 11, 12, and so on, 14. You do not have the odd number in this case. And this is the next table, 16, 18, 20. So you will look at this one. If the number of seed planted is 20 and the probability that a seed will germinate is 0.4, what's the probability that exactly 10 seed will germinate? 10 or more seed will germinate. So for part A, you still can use the formula. But for part B, 15 or more seed will germinate. Either you use the direct method or complementary method. You involve many calculations. So for example, if you do the direct, you have to calculate x equal to 10, that's it, r equal to 10, 11 until 20. So it will be taking you a very long time to work out. Same thing, 15 or fewer will germinate. If you use direct method, you will have to calculate x equal to 0, x equal to 1 until x equal to 15. And then the last part here, determine the expected number of seeds that germinate. There is a formula that I will show you later on. Let's look at the table in this case. So you will look on the table when n is 20 and r is the number of tries. So this table is for probability x greater or equal to r. So our calculation must convert all the inequality to greater or equal to r. So for example, when x has a binomial distribution of n equal to 20, you look at the table, locate the table with n equal to 20. And we look at the example there, we know the probability is 0.4. You look at the top row here, this is 0.40. For example, if I want to find x greater or equal to 2, I will look for r equal to 2. Then under the column here, under the 0.40, you will get the answer 0.9995. So your answer is 0.9995. So you need not have to use a formula to work out for x greater or equal to 2. until you get 20. So that is a lot of calculation. Of course, you may use indirect method. Now, for x greater or equal to 10, you look for r equal to 10. Then you look for under the column here, the probability 0.40, you will get the answer at 0.2447. If you are asked to find exactly px equal to 10, you have a choice to use calculations because this is just one calculations, or you may use this formula, greater or equal to 10 minus px greater or equal to 11. If you look at x greater or equal to 10, we already have the answer 0.2447. Now we will look at greater or equal to 11. So you look at the next number, r equal to 11. And you shall get the answer 0.1275. So you sub in the answer you get. Then you calculate, you shall get 0.1172. So please look at the video again to see how we work out all these values. Now we go back to the question. Exactly 10 seeds will germinate. So we use the formula given for x equal to 10. It is greater or equal to 10 minus p greater or equal to 11. So we have seen in the table, this will be your answer. Now part B, or in the part A, you can use calculation because it is quite straightforward. You use the binomial distribution formula and you work out, you should get the same answer. Next, 10 or more seeds will germinate. So 10 or more seeds is x greater or equal to 10. Have you seen in the earlier slide from the table, the answer is 0.2447. So we cannot calculate from 10 x equal to 10, x equal to 11 until x equal to 20. So we need to use the table as shown in the earlier slide. So 15 or fewer seeds will germinate. You will have less than or equal to. So we'll use the indirect method. So 1 minus px greater than 15. So look at the first slide I show you in this video. To x greater or equal to 15, you must change it to x greater or equal to 16. Because the table must have the equal sign. So look at the table. You'll get the answer at 0.003. Then your answer for 15 or fewer seeds will germinate. The probability is 0.9997. So hence determine the expected number of seeds that germinate. So in this case, please remember this is the expectations, or sometimes it's the mean. The formula just take n times p, the number of tries and the probability of success. That will give you the expected number of seeds that germinate. So our n is 20, probability is 0.4. Therefore, the answer is equal to 8. So please look at the table again and again until you are familiar. And do use the table, the first slide, to convert it to the probability greater or equal to. Now, we look at the next example. The manufacturer of a bag of sweets claims that there is a 90% chance that the bag contains some toffees. If 20 bags are chosen, what is the probability that all the bags contain toffees? So in this case, we have only one calculation. You can use the table or you can use the formula. So please look up and check whether your answer is 0.1216. More than 18 bags contain toffee. So here again, you may use a table, or you need not have to use table, because more than 18, our maximum is 20. So if you were to do the calculations, it only involve x equal to 18, x equal to 19, and x equal to 20. X equal to 20, we already get the answer from first part. The answer you get should be 0.3917. More than 15, more than or equal to 15 bag contain toffee. So the answer should be 0.9888. So you may use the table or use the calculation, because more than or equal to 15, the x equal to 15, 16, 17, 18, 19, and 20. So 18, 19, and 20, we have the answer from here. Okay, so please pause the video and do the calculations or use the table, whichever you are familiar with. Once you have done this and you get the answer and you want to check your calculation, you may continue to look at the next slide here. So you know that you have 20 and the probability of success is 0.9, so n is 20. So all the bag contain toffees. Use the formula, 20C20 times 0.9 to the power 20, and 20 minus 20, the probability is 0, the power is 0. So you work out, your answer should be 0.1216. More than 18 contain toffees. So if you have more than 18, you must change it to greater or equal to 19. So you have to calculate PT equal to 19 and T equal to 20. So T equal to 20, we already have the answer from part A. You only need to use the formula for R equal to 9. So please use your calculator and work out. So the answer for first part of the calculation should be 0.2702. Your answer should be 0.3918. More than or equal to 15 bag contain toffee. So in this case, you may use a table. So please use a table and check. And here I will show you the calculation. It is because you already get part of the answer from part A, part B. So please compare your answer from the table and from the calculation here. Choose whichever method you think is easy for you. So we have PT equal to 15, 16, 17, 18, 19, and 20. So 19 and 20, we already get the answer from part B. So what we need to do is calculate the answer for R equal to 15, 16, 17, and 18. So 19, so you are going to get 0.3918 for 19 and 20. So you need to calculate the R equal to 15, 16, 17, and 18. You may pause the video. Of course, if you find that this is too long, please go to the table. You have to change because there is no probability of 0.9 in the table. You have to use the indirect method, which I'm not going to confuse you and show. So probably some of you may have learned. You may try to change to the complementary method. So here, I would suggest you use the calculations. So please calculate. So you work out your answer for each of part. You should get all these 0.03192 and so on. Your final answer should be 0.9888. Now question 11. By some estimate, 20% of Americans have no health insurance. A random sample of 50 Americans is selected at random. Find the probability that 3 have no health insurance. Most 1 has no health insurance, and more than 7 have no health insurance. So let's look at the working, or you can try to count. So you may use the table to help you to get the answer, or you may use the calculations. So like part A and part B, the calculations should be quite easy. For part C, it will be quite a lot of calculations if you have to use the calculation method. So please pause the video and work out this. So let's look at the answer after you have completed. So you have 15 for your N, and probability of success is 0.2. 3 have no health insurance. So very straightforward. Let's use the formula. Pause the video, get your answer, and check. And part B, at most 1 has no health insurance. So this includes the case of x equal to 0 or x equal to 1. So use your calculator and work out. Your answer should be 0.1671. So in this case, more than 7 has no health insurance. You change to greater than 7 to x greater or equal to 8. Then you may have to do the direct method. You have to do all these calculations. You see there are plenty of calculations here. That would be the answer. Please go to and try to use the table, see whether you get an answer of 0.0035 from the table. Right? If the question did not specify a number of decimal places, you can leave it up to 4, 5, or 6 decimal places. Okay, so that is the end of this topic of binomial distributions. If any of the questions or example that you do not understand, you may ask your lecturer during the consultations or seminar or support class, or making one-to-one consultation. Thank you, class.